Alright, we are now going to look at adding complex numbers. Alright, so I have my two examples on the board here. Looking at this very first example, the first thing I would observe is I see that there's a plus happening, so this does not change the signs happening inside my parentheses. I'm sorry, something I did want to say actually is adding complex numbers and subtracting complex numbers is identical to what you would do with polynomials. That's why polynomials and complex numbers are actually paired together. Alright, so we can rewrite my expression without parentheses, with all my parts together, and none of the signs change. So now I have a 6 and a plus 1, becoming a 7. I have a negative 4i and a negative 3i. Now remember, we're not multiplying here, we're just adding and subtracting. So we have negative 4i minus 3i, that'll give me minus 7i. Okay. And actually, now that I'm looking on the notes here, your example in your packet is actually a plus. So this would really become a plus. So what you could change this to is negative 4i plus 3i becomes minus I. Either works. You've actually now just seen two different examples. So now looking at this one, you have to be careful because my minus in front of my second set of parentheses is going to change the sign. So we can rewrite this as 3 minus 2i. This will become a minus 5, and now it will become a plus 4i. It's important not to just erase your parentheses because you could forget to distribute that negative, which in turn change the sign of my 4i. So once again, we have 3 minus 5, which is negative 2, and we have negative 2i plus 4i. That creates plus 2i. There you go. Alright, we are now going to look at multiplying complex numbers, and this is identical to actually multiplying polynomials. We did the box method already in class, and so you can do box method. And for examples such as this one, it's actually why I chose the box method. The expression 2 minus 7i being raised to the second power, you have to remember that you're not just squaring each term individually. We could expand this expression to just being 2 minus 7i times the quantity 2 minus 7i. There's two of them. Alright, so now we're just going to FOIL it. So 2 times 2 is 4. 2 times negative 7i gives me negative 14i. We have negative 7i times 2, that's also another 14i, but negative. And the last one, negative 7i times negative 7i, that'll give me positive 49i squared. Alright, I'm not done yet. I have to combine my like terms, but I also have to go a step further. When multiplying complex numbers, I have to remember that I squared is actually equal to negative 1. So this is really being 49 times negative 1, which will create my expression to have a minus 49. Alright, inside here, we also have a 4. These are actually now like terms. So we actually have a 4 minus a 49. This will create negative 45. These guys are also like terms. We have negative 14i and negative 14i. That creates negative 28i. Alright, let's look at another example. This one looks really intimidating, but it actually is not all that bad. All it did was added letters. So let's FOIL. A times 3a gives me 3a squared. A times negative bi will give me minus a bi. 2bi times 3a, that'll give me plus 6 bai. It's important to recognize abi and bai are the same thing. Lastly, we have plus 2bi minus bi multiplied together to give me minus 2. The b is being squared and the I is being squared. Alright, so now we have to simplify. So we have 3a squared. These guys are like terms because we have a minus abi and a plus 6 abi, giving me plus 5 abi. Now this guy, minus 2b squared I squared, we have to remember that 2b squared is being multiplied by negative 1 because I squared is actually just negative 1. This will change the sign of my monomial. to plus 2b squared. And that's it. All right, we are now going to look at what's called a complex conjugate. All right, so if a complex number is a plus bi, a complex conjugate of this complex number would be a minus bi. All that happens in a complex number is you flip the sign in front of the imaginary number part. So for example, if my complex number is 3 plus 2i, my complex conjugate would be 3 minus 2i. The sign's flipped. Now if my complex conjugate had been 3, let's say, my complex number had been 3 minus 2i, the complex conjugate would be 3 plus 2i. All you do is flip the signs. The next thing I want us to look at is a wonderful phenomenon that will happen actually when you multiply a complex number by its complex conjugate. So let's do it. 3 times 3 gives me 9. 3 times negative 4i will give me negative 12i. 4i times 3 will give me positive 12i. And lastly, 4i times negative 4i will give me negative 16i squared. Now we have to simplify. The key point, the main idea here, when you multiply a complex number by its complex conjugate, the middle terms will go away. The reason we flip the sign is so that they cancel out when we multiply them. Another thing that's important is we have minus 16i squared, which we know is negative 1. We're completely eliminating the imaginary number part. That is why when we get to division, we'll use complex conjugates. So, negative 16 minus 1, that will become plus 16. And we also still have our 9. We have 9 plus 16. That gets me 25. So in case you weren't listening before, the key idea here is we're really having, I don't know if any of you noticed, a difference of squares. Okay? This is why we're multiplying by the complex conjugate. When we do this, the I part goes away. And that will be the complex conjugate.